Assalamualaikum dear students, welcome to the White Chalk Academy, and this lecture is purely for class 10 students, although the rest of the classes can also study it, but today we will teach it in such a detail that every great student can get proper knowledge from this one. So let's take a start. What is law of mass action? Law of mass action is a general relation. This is a general relation between the concentration of reactant and product at equilibrium in a chemical reaction. If we take a chemical reaction, for example, we have nitrogen reacting with hydrogen, and the product we get, that is ammonia. So now it's a general relation between these two products and reactants. Now on the right hand side we have ammonia, which is our product, and the left hand side we have nitrogen and hydrogen, which is our reactant. So now law of mass action is basically a general relation between these two left and right hand side, law of mass action. So we have a few equations which I am going to discuss, but before that let's move toward the statement. The statement is that the law of mass action states that the rate at which a substance reacts is directly proportional to its active masses. So what is basically the statement? If you give a proper heading, that is statement. So the rate at which a substance reacts, so we can write that rate at which substance react is directly proportional to the active masses of reactants and products. Now what are active masses? So let's move toward a diagram. I am going to explain it from a proper diagram. We have a beaker. The width is around 10 centimeter. We have another beaker where the width is around 15 centimeter. In both the beakers we have some liquid. You can see that. Now if I ask you that both are placing in open atmosphere which completely receiving sun rays, so from which beaker most of the particle will evaporate? So for example, here 3, 4, 5 and 6, here we have 3 and 4 particles. Now in this case, in the you can say the bigger beaker, we have 6 particles on the surface which are ready to evaporate from the surface, or we can say escaping from the surface through the process of evaporation, while in the beaker where we have the width of 10 centimeter, 4 particles on the surface of the earth. Now it is quite clear, and everyone knows that from this beaker, as it have a greater area, surface area, so the most of the particle will evaporate, while in this beaker it has a lesser surface area as compared to that one. Less particle will be escaping or evaporates from the surface. So what is meant by the active masses? Now these are the particles which are playing active role, because they are responsible for the process of evaporation, while the rest of the particle are lying beside or beneath these surface particle. So active masses mean, now I am going to tell you that the active masses mean, here we are putting some proper headings, those substance from reactants which play active role or actively participate in chemical reaction. Those particles which are participating actively in a chemical reaction, those species, those substances are called active masses. Now we are showing the active masses from a square bracket, For example, we have a reaction A plus B that gives us C plus D. It is a reversible reaction. You should keep in mind that the law of mass action is favorably for the reversible reaction. Now here, if we show these A and B in square bracket, so it means active masses. Now what does that bracket mean? So this bracket means square bracket, and this square bracket shows concentration. We can show concentration from C, that is equal to N by V. So N is number of mole having unit mole, V is volume having unit dm cube. So it means that C is equal to mole per dm cube. So if we show a substance from the unit of mole per dm cube, it means these are active masses. So hope you guys, you are getting what I have told you. If it is clear, if there is any question you can ask in the comment area, but if it is clear, so let's move toward the chemical reaction from where we can get the Kc. So rate of forward and backward reaction, and then we will get the Kc, and after that we will get the equilibrium constant expression. So this is our checklist. We are doing that statement, active masses. Now we are moving towards the reaction. So take a screenshot and let's move toward the next heading. So okay guys, we have a general reaction, that is A plus B, a reversible reaction where a product is C plus D. So we can write that rate of forward reaction, that is Kf, directly proportional to the active masses, so A and B. While rate of reverse, sometime we can call this backward reaction. So reverse reaction is directly proportional to K, R, C and D. So now if we change this reaction and we write it with the proper coefficient, so what will be the expression? So according to the law of mass action, putting a heading, according to the law of mass action. So we are writing a general reaction, that is A, B, B, and give us C, C in small d and capital D. Now our reactant side, our product side. Okay, so now let's remove this one. Okay, now write a similar statement for this one as well, that is rate of a forward reaction Kf. So now A, where will go this coefficient will be now exponent, will raise to the power of that species, and B, similarly rate of reverse reaction, so Kr, C power C and D power D. Now by cross multiplying both the statement, here you can do one thing. If you remove this one and this one, from here this one and this one, so now let's make it very easy. Okay, rate of forward reaction, because we have to put rate of forward reaction is directly proportional, is equal to A and B, and rate of reverse reaction KR C power C and D power D. Now we have removed this proportionality sign with these two constants. The first one is for the rate of forward reaction and the second one is for the rate of the backward reaction. Now at equilibrium, Kf and Kb will give us Kc, but before going there we are writing that Kf and Kr, Kf and Kr constant for rates, rates of forward and backward reaction. Now at equilibrium what will happen? So let's draw a line. At equilibrium stage, rate of forward reaction will be equal to rate of backward reaction. So rate of forward reaction will be equal to rate of reverse reaction. It means Kf will be equal to Kr. So now if we write this Kf A power A B power B is equal to Kr C power C and D power D. So by cross multiplying we will get this Kf by Kr is equal to C power C D power D divided by A power A and B power B. So now you should know that Kf by Kr that is equal to Kc. Equilibrium constant. What is Kc? Equilibrium constant, where C shows concentration. If we take the species, now keep in mind this point is quite important, that if we are going to take the species in mole per dm cube, we will write C. If we are going to take the species in a gaseous form, for example, for that we use the unit of partial pressure. In case of mole fraction we use the unit of moles. So then this statement will be changed. In case of gaseous it will be Kp. In case of mole fraction this C will be replaced by X, so it will be Kx. You should keep that in mind. Someone can ask this in your Viva or in a MCQ, so you can underline it for the MCQs. So now this reactions become like this one. Kc will be equal to C D divided by A and B. Now this is a equilibrium constant expression. So now we are actually discussing this one, where C brackets show concentration equal to N by V. These are exponent. In first step they were coefficient. Actually both of these are products, both of these are reactants. Okay, and this is a equilibrium constant expression. So now you can label this equation. After that we are going to discuss the definition of this this chemical equilibrium constant expression. So take a screenshot and then we will move towards the next one. Okay guys, this is the label equation. Now what will be the definition? The definition is definition of Kc, that ratio, because it is ratio of product to the product, because this is product, because the two species are multiplying. So in mathematics we call this the product or multiplication. but in fact these were the species products in the chemical reaction, C plus D, P. So ratio of product to the product, product to the reactants raised. Now that is the product of product, and in the denominator we have the product of the reactants. Now raise to the exponent, raise to the exponent of their coefficient. Now this exponent was in fact coefficient in the original reaction, which we are saying number of moles generally. So this is the definition. You can remember this from here, because from the books you will not it very much clear. So that's why I am telling you that you should focus here, that it is the ratio of product to the product, product of the reactants to the exponent of their coefficient. So this is the definition for the what? For the Kc. Now we should have conditions for the equilibrium. What are the conditions for the equilibrium? So we should write a proper heading, condition for equilibrium. Under which condition we can get the equilibrium? So the first one should be, we cannot attain equilibrium in open container, because from the open container, for the equilibrium we should have the reactants and products both. This can be done if we have the substance in a closed container from where it cannot escape, but in open container the particles can evaporate and escape through in the atmosphere. So that's why we can't get the product. If we can't get the product, then we can't get the reactants back from the product. So that's why we cannot attain equilibrium in the open container, but we can do this, but we can attain this in the what? In closed container. That is the number one thing. The second one, if a system reaches equilibrium, it will stay until. So until what? If an equilibrium established between the two species, so it will remain in the equilibrium until. So until one changes the condition, Now what are the conditions? So the conditions are pressure, temperature, concentration, volume, and catalyst. These are basically the condition. How can these species disturb the chemical equilibrium? Let's suppose we have the reaction for the ammonia preparation. Suppose we are changing the pressure, the reaction are moving in this direction. If we change the temperature, it depends the reaction, it is endothermic or exothermic. In case of endothermic, reaction will move in forward direction. In case of exothermic, reaction will move in the backward direction. The third one is concentration. If we increase the concentration on this side, the reaction will move on this side. If we decrease the concentration on this side, reaction will move on this side, and vice versa. Volume. If we are going to increase the volume, reaction will move in a direction where the volume is lesser as compared to the next one. So 1 and 3, 4, here 2. So reaction will move in this direction. And the final one is the catalyst. Catalyst basically changes the rate of the reaction. We are using the catalyst for the reaction. If you want to complete this reaction, if you want to get the product in a lesser time, if we are in a hurry, so then we are using the catalyst. Catalyst basically increase the rate of the reaction. So what does that happen if we increase the rate of the reaction? Rate basically the change in concentration, the consumption of the reactant or the product per unit time, which is second. So if you are going to increase the rate, it means in lesser time you will get maximum product, and from the product you will get maximum reactant. So that's why we are using the catalyst. So guys, it was all about the law of mass action. If you have any question, you can ask in the comments area. But before completing the lecture, you should subscribe the channel, share with your friends, and let the other people know about the topics. So we will bring some more lectures from some brilliant teacher and some outstanding subjects which are fully relevant to your courses. Inshallah, we will see you in the next lecture. Till then, Allah Hafiz.